Alright, last part, problem 2, part D. So part D, they want you to find the PDF for x over y. So that means big F of z is going to be integrated over the area where x over y is less than or equal to z. So I rearrange this so I can write it as y is greater than x over z. So because x has to be greater than 0 and y has to be greater than 0, we only consider this area over here. So where y is greater than this function, but only where x is greater than 0 and y is greater than 0. So big F of z is equal to this integral. Now I'm going to integrate with respect to x first. So x is going to go from 0 to what? X is going to go from 0 to this function, which is y times z. Right? Because y is equal to... The line is y equals x over z. So the x points are going to be y times z. Now, y is going to be integrated from 0 to infinity. So this becomes integral 0 to infinity. Oh, I forgot here. I forgot my dy. Dx dy. Sorry about that. I have e to the minus y. This integral, the x integral, is going to be minus e to the minus yz minus e to the minus 0, so that becomes plus 1. And then we have a dy here. So I'm going to distribute the e to the minus y. So I have integral 0 to infinity. We have minus e to the minus y. Right? So it's going to be minus y minus yz. So I took out the minus y, so I get 1 plus z dy. Then I have plus integral 0 to infinity of e to the minus y dy. So this guy is going to become what? It's going to become minus 1 over 1 plus z times times minus e to the minus infinity, which is 0. I'm sorry. 1 second. Right. Which is 0. Then minus becomes a plus. But we still have this minus here because we have another minus. So it's going to be this times e to the 0, which just becomes 1. So it's just going to be this guy. I'll you know what? I'll write it more explicit. Let's do that. So we have minus e to the minus infinity, right? And then we have minus becomes a plus, and then we have e to the 0. So it just becomes 1, but this minus survives. So plus this guy becomes 1 because we know minus e to the minus infinity is 0, and minus e to the 0, right? We have 2 minuses, which becomes a plus. So here we get a 1. So this goes to 0, and this goes to 1. So we're left with 1 minus this. So this becomes 1 minus 1 over 1 plus z. Okay, so little f of z is the derivative with respect to z of this guy. So the only place that has z here is this, so we want to take the derivative of this. So what's the derivative of that? Well, I'm gonna write, this can also be written as 1 minus 1 plus z to the minus 1. So it's going to be, we have the minus here. Right, so the minus 1 comes down. So we have a minus already. Then the minus 1 comes down. And then we're left with 1 plus z to the minus 2, which is in the denominator. We have this. So this is just going to become 1 over 1 plus z squared. Now remember, because x and y are positive, that means that z is also greater than or equal to 0. So this is for z greater than or equal to 0. Alternatively, we can write little f of z as 1 over 1 plus z quantity squared times u of z, using the step function. So that is the PDF, and that completes part D.